Let's take a look at some current trends in academia. The first of which is the use of GPT-3, which is one of the largest unsupervised language models. Language models are more complicated and outside the scope of this discussion, but they essentially are trained off of a large data set that isn't labeled. In this case, we call that unsupervised. And what this algorithm does is it goes and finds all the articles, blogs, and any text that web crawlers can find on the internet, organizes that data based on a series of metadata, and then it has hundreds of servers trained on this model for several months. And what you end up with is a very large language model that essentially does a great job of sequence prediction. So given the current word, you can figure out what the next words might be. And this isn't something new per se. We've had sequence models in the industry for a while. However, the scale at which it is being done now and the size of these models, how much data we're using to train, is really what's different. And as a result of that, we've seen some very impressive and remarkable results with GPT-3 alone. It's been able to outperform a lot of task-specific models for things like question answering or entity prediction, etc. with just this single out-of-the-box package. Now, it does have its limitations. This paper goes over some of the limitations of GPT-3, and the main limitation of GPT-3 is that we don't exactly have full control over how it responds. We can only kind of guess based on something called prompt engineering. So prompt engineering is when you give the language model a prompt that might uncover a certain pattern that it will recognize, and based on that prompt you will get a set of responses. However, it's not necessary that those responses are actually meaningful or align with the intended use of that prompt. And so prompt engineering exists because it takes a while to figure out what is the right way to prompt the sequence model to get the kind of output that you're looking for. Now, of course, work is being done on this, but as it stands now, there is no full control or understanding of what these models can make. And as a result, you may see output that is not appropriate, maybe divides people in different ways, etc. Some other interesting applications in conversational systems is the use and integration of emotional intelligence. Now, the entire way of capturing emotion and being able to train a system on that is something that is open to debate in research and is being approached in a number of ways. However, the ultimate goal here is for chatbots to better understand the emotional state of the user and thus improve the overall experience with the user. Now, going even beyond that, we also see that there's been a recent trend towards multimodal chatbots. These chatbots can take into account not only the text of what's being communicated between the user and the chatbot, but also any images that might be referenced. In this case, you can see in the example on the right, a visual chatbot is able to recognize that the image that was entered is a cloudy sky with clouds in the background. It analyzes the image using a CNN architecture and uses a recurrent neural network for the text processing. There's some architectural setup in which both algorithms are being used in conjunction in order for this to work. And the paper mentioned here goes into more detail about that. But overall, we see that conversational assistance is a subject that is really hot in the research community and is being actively worked on. There's a lot of growth here, a lot of potential impact on industry as well. So